All right, back to stats videos. Coach Owings, hello again. Today we're taking a sample from a population. We'll use the average from the sample to estimate the average for the population. So we're going to start with a very simple example, talking about the midterm exam, even though we don't have midterms here in Frisco ISD. Let's say there's only 4 people who took the midterm, and we see their scores right here. So we're going to first take a sample of any 2 of the scores, and we're going to find the mean of our sample. So let's get a little drawing tool here. So let's say we have 70 and 90. What we're going to do, this is our sample right here. And so what we're going to do is we're going to find the mean of our sample. We want to find our sample mean, which again we label as X bar, a little refresher there. So we're going to find the average, we'll add them together and divide by 2. And so we get a mean of 80 for our sample of 2. So next we're going to figure out all possible samples of size 2, and we're going to calculate a mean for each sample of size 2. So I'm going to write them all down. So we have 60 and 70, which gives us a sample mean of 65. We have 60 and 80, which gives us a sample mean of 70. We have 60 and 90, which gives us a sample mean of 75. Let me go over here. And we have 70 and 80, which gives us a sample mean of 75, 70 and 90, sample mean of 80, and then 80 and 90, which gives us a sample mean of 85. I left blanks there because I do want to write in X bar for all of these. So we want to use those. We're going to make a dot plot of all those means. So I'm going to pause real quick, hop over to Staplet and make a dot plot. So hang on right there. So hopefully you're familiar with staplet.com and you're able to just type all that information in and begin analysis and create a dot plot. So I'm going to leave some room here because I want to write stuff to the right of it. Get out of here, face. And so we want to talk about a few things. First, we want to talk about what each dot represents. So each dot represents a different random sample of size 2 and a mean calculated from the sample. And then what is the true mean? Well, we see in our summary statistics right here what our actual mean is. Let's look at how to calculate that. So our true mean, remember that's our population mean, which we label with mu. We'll write down a mu again right here. We're going to take 60 plus 70 plus 80 plus 90, add all those together. So we got to make sure we have parentheses around those, and then divide all that by 4. And that'll give us that the true mean was 75. So in order to draw a mu, remember it's like a U with a big tail in front of it. So what we just did here, as you can see in the label of our dot plot, that's called a sampling distribution. It shows the means calculated from all of the possible samples of size 2 from a population. So a couple quick things is that X bar, which I'll rewrite there in a second. That is a statistic, and that comes from a sample. Whereas mu, I'll write down what a mu looks like there again. That is a parameter, and that comes from a population. So these terms are very similar, but a good way to remember them is the first letter. So X bar is a statistic from a sample, S&S, and mu is our parameter from a population. So just keep those in mind. So continuing on, in reality, and there weren't just 4 kids who took the midterm, there was dozens and hundreds of them. Right, that midterm that we take every semester. So what we could do instead of figuring out the mean for everyone is to take a random sample of 5 students and record their scores and find that mean. So ways we can do that is we can use random.org or the calculator or ask Siri, give me a random number between 1 and 146. So we had 146 kids take this midterm exam. We have all the data right here on the next page. And so I did that a bunch of times, and I recorded the mean from each of those. And I wrote the mean on, and basically I plotted a dot plot. So let me go get that dot plot real quick from Statlet. We had everyone round to the nearest whole number, and so we get a beautiful looking graph like that. We got a couple questions to answer about that graph. So first question says, what does each dot on this poster represent? And so each dot on that represents a sample of 5 midterm scores and a mean calculated from the sample. So a sampling distribution, kind of one of the part of the topics today, shows the means calculated from all of the possible samples of size 5. Is the above dot plot a sampling distribution? Well, we didn't really choose all of them. There's many more than just 38 different samples of size 5. So technically, no, there are many more than just 38 samples of size 5 out of 146 data points, but that there's just too many. We can do 146 choose 5, and that would get us how many there are. And if y'all put that in your calculator, go to a website that'll do that, then you'll see that's entirely too many. It's too much tuna. So, but it is close enough for us to use this as a sampling distribution. So we took a random sample of 5 scores at this high school and got a mean of 68. So that's a different high school. So ours on this graph here looks like we don't have many scores below 68. In fact, out of these 38 scores, it looks like how many were below. It looks like 1 out of 38 was at 68 or below. So that 1 out of 38 is pretty low. So so this mean actually up here, if we have the mean of all that data, it's 76.8, and that's actually pretty close to the actual mean. The actual mean is 76, the actual population mean. So that tells us that mu is 76. So if we're saying that another school got 60, a random score of 68 or lower, that doesn't happen very often. That happens 1 out of 38 times we took a sample mean from our data. So if this other school gets 68, then that's not going to happen too often. Maybe we want to run it a few more times, see if we still get something close to 68. But assuming the other school has the same mean, population mean, mu, equals 76, then there is a 1 out of 38, which when I divide 1 divided by 38 gives me about 2.6% chance of getting a mean of 68 or lower. So because that's so small, that's statistically significant. We can say we have convincing evidence that the other high school's mean is lower. So we would say that's statistically significant and spell it correctly. I'm going to come back with another video very shortly, and we're going to talk about the next page here, and we're going to take a bigger sample size of 10 data points and see what that looks like, and then we'll wrap up with some important ideas.